At this stage, you should be moving quicker than I am with your logic behind the questions. So feel free to skip various steps. For part B though, there is a bit of a trick, and I'll read the question after giving you a chance to do it, and I'll explain what the trick or the thing that's difficult to spot is in that question. Okay, so the strategy, right? Is there a differential equation? There's a 25 minus 10v is equal to a, so that's a differential equation. Is it increasing or decreasing? Well, the acceleration is dv dt, and the v thing has a minus in front of it, so it's decreasing. So this is actually a deceleration. What are the variables? It's likely the variables are v and t, and the constants are numbers. What's happening here? Well, if the acceleration is 25 minus 10v, or dv dt is equal to 25 minus 10v, it's going to be a decreasing log function with a starting value probably of 25. So it starts off at a speed of 25, and then it decreases, or the object decreases speed by 10 every time its velocity increases by 1. Okay, so you should be able to use the fact that the particle starts from rest to get part 1 via integration. And then part 2, we can see there's actually 2 questions there. Find the time taken to get that speed, so I'll leave acceleration be dv dt, and use your initial conditions, and then the second set of conditions are find t when v is 2.25. The second set of conditions are find the distance travelled in that time. So in that case, you'd use the acceleration as v dv dx. You're looking for x, and you have t there from the first part of part 2. All right, should be fairly straightforward. Second question. Pause the video and go through the tips. Okay, you should have that done. Now there's a little bit of a trick here, and I'll read the question straight away. A spacecraft moves in a straight line towards the Earth. So the spacecraft is going from P to O. Radius of the Earth is r when P is at a distance x from O. So that means that P is away from O, and away is very, very important there. There's a force exerted towards O. So the distance is away, the force is towards, which means that these are in the opposite direction. So there should be a minus there in your formula somewhere, and that's important to spot. Now we're told that the force exerted has a magnitude of k over x squared. The giveaway is the magnitude actually. So the magnitude means it could be k over x squared or minus k over x squared. And what I'm saying is the distance is away, the force is towards, they're in opposite directions, so the force will be minus k over x squared. F is equal to ma, so ma will be minus k over x squared. A then is equal to minus k over mx squared. With that, you should be able to pick out your initial conditions, which are when t is equal to 0, the distance is equal to x, and you should be able to get a formula there of some shape or form. Okay, for the second part, it says P starts from rest when it's a distance. P starts from rest when it's at a distance of 5r. In that case, you're given t is 0 when v is 0 when s is equal to 5r. So we could either be going time and velocity, or we could be going velocity and displacement here for the acceleration formula. So let's have a look at the question, and it says find in terms of r the speed as it hits the surface of the Earth. We're looking for v, and when it hits the surface of the Earth, we know the x value is r. So we're looking for a formula with v and x. So if your original formula for the acceleration is minus k over mx squared, we're leaving the acceleration be v dv dx. Okay, I've gone through that. Pause it and do the question. I'm going to go through the tips as though I didn't say anything to you yet. So, number 1, is there a differential equation? Well, there's definitely a k over x squared. Okay, I don't know right now if that's an acceleration or a force, but if I was a betting man and I'm looking at the system here with spacecrafts and stuff, it's definitely one of the two of them. I would probably just have a quick glance through it and I see force exerted. So I'd set up then force exerted is equal to k over x squared. I then see the word magnitude and I get all worried, and I'm thinking that could be positive or negative, because if it was equal to k over x squared, they would say equal to. So it's likely it could be a minus there as well. So I'm going to have to do some more reading of the question. Now let's have a look at the variables. X is a variable because it's the distance from the Earth, and the force is a variable as well. That means the acceleration is a variable if I need it. And we're probably dealing with accelerations here, dv dt or v dv dx's. So velocities, displacements, times, those are going to be the variables, or combinations of those are going to be the variables in this case. The x is going to be a constant. In my diagram, the r is the radius of the Earth. That's going to be a diagram, and the mass of the Earth is going, not a diagram, a constant, sorry. R is going to be a constant, m is going to be a constant. So what's happening? All right, let's read it. So, spacecraft of mass m moves in a straight line towards the Earth. Okay, radius of the Earth is r. Okay, when p is at a distance from x from O, so the x value is measured towards the top right-hand corner. The force is exerted in the opposite direction, and that tells me that the relationship between the force and the displacement, there needs to be different signs between the two of them. So my force is going to be minus k over x squared. Now you should be able to do it from there. I've already explained it, and I've already explained the bottom one as well. All right, so let's have a look at 2016. Again, pause the video before I get into it and see can you identify it and do the question. If not,